Hello and welcome to this presentation on Qt Quick Best Practices and Design Patterns. My name is Girish. I'm an ex-troll. I used to work with Trolltech back in 2005, so some of you might have seen me before. I'm the author of Qt Style Sheets, Qt Completer, and lots of other things in Qt like graphics widget layouts, widgets on the canvas. I also worked on the widget stuff, Q message box, Q label. So I worked on all that stuff when I was in Trolltech. I left Trolltech back in 2007, and I started my own company called Forward Bias Technologies back in India, in Bangalore. These days, I hack on WebKit and Qt Quick and Calligra. If you have any questions, in fact, related to Qt WebKit, feel free to grab me after this talk. So I started working and studying on QML like about a year back. I started looking at all the examples and reading up on the demos. Most of the stuff worked really great. One of the things I saw is that all the examples were like quite small. So I wanted to actually see how well QML works, both performance-wise and design-wise, when applied to large-scale applications. So what we did is two employees from Nokia, Johannes and Donald, and myself, we started an open source project called the Qt Media Hub. Qt Media Hub is essentially a clone of XBMC. For those of you who don't know XBMC, it's a media box. Okay, it's a media center using which you can browse your pictures, videos, and music. What you see here are essentially two skins which are implemented completely in QML. This talk is essentially about what we learned during designing Qt Media Hub, what we think are the best practices that you should use for QML for large-scale applications. By the way, we have Qt Media Hub running on a variety of devices, and you can actually go to the Qt center right there, and you can play with these things live. So here's my agenda for the today. I'm going to explain what I think is the best way to design large-scale QML applications. I'm also going to show various QML tricks and less-known features. I've been told that some of the slides are very dense. It's kind of hard to follow. This is actually an advanced talk. So I'm going to ask, how many of you here have actually used QML? That's awesome. This is going to make my talk much better because I think it's like 90% of you raise your hands up. So QML, as we know, is a JavaScript-based declarative language. If you look into the default QML elements, most of them are user interface related. You have rectangles, images, list views, all the basic UI stuff. If any of you have actually tried making a serious app out of QML, you will quickly notice that you need extra QML elements. And thankfully, QML provides a way by which you can extend QML through C++. You can register C++ types, which can be used in QML. You can take existing C++ objects and register them in QML, which we'll see in the future slides. But what I want to talk now is how do we decide the split? What goes into the C++? What goes into QML? When we initially started the Qt Media Hub project, we were like learning QML and JSON for the JavaScript for the first time. And we were like putting as much as possible into the QML. All the business logic, as much as possible, we would just put it in the JavaScript side. What we found is basically two disadvantages with this approach. The first disadvantage is that the JavaScript stuff is actually quite slow on the embedded targets. So we wanted to sort of move all our JavaScript business logic into the C++ side. The second thing which we found is that when we started a new skin, so as you see here in the previous slides, I think currently we have like 6 skins. When we started writing a new skin, we found out that part of the business logic is in the JavaScript world, part of the business logic is in the C++ world, and now we have this new QML UI which we need to write up, and we have to suddenly copy all the JavaScript code from this skin into another skin. This is bad because of two things. There is actually no way for us to share JavaScript code, because in Qt Media Hub, skins can actually be written by third party. So if I write my own skin, there's no way I want my JavaScript to be shared with others. That's one problem. Yeah, actually, that's the only problem. Yeah. So the pattern I'm going to introduce you guys is the model view pattern. This should be known to pretty much any programmer today. I want you to think of the C++ as the runtime, as a provider of services. You can even take it further and think of it as something like the operating system. And the operating system provides system calls for your applications, right? So think of the C++ runtime backend as a provider of services, system calls. The QML is a pure presentation layer. It just does UI stuff. It takes in user input, and it feeds whatever the action is inside the C++ runtime. The most important thing is the arrow. It's a one-way traffic, right? The QML depends on the C++. The C++ does not depend on the QML. If you ever find yourself writing code which evaluates stuff, evaluates some JavaScript code from C++, if you try to find QML elements from C++, you're doing it wrong. You shouldn't be doing all that, right? I believe if we follow this approach, we are actually coding to QML Strength. QML Strength is the ability to create user interfaces and to create user interfaces fast. If you have the split of this, you have this model view split or the front and back end split, you can create multiple front ends. So if you have 2-3 designers on your team and you want to play around with different types of UIs, as long as you have all the business logic in the C++, you can create a complete new QML user interface. This might seem to be something really specific to Qt Media Hub. I mean, you can say, Qt Media Hub must have multiple skins, so all this stuff makes sense. But really, if you think of your application, you might want to move it to another device. You might want to target multiple platforms. And then you might want a completely different UI. If you had this split to start with, all the C++ stuff has the backend things, and you can have a completely different UI based on the platform. And of course, the nice thing is, on the C++, you can use if-defs, right? Whereas on the QML, it's actually kind of hard to do if-defs at a platform level. So I just wanted to go over the thumb rules of this pattern. Don't ever access QML and UI stuff from C++. There are lots of classes like QDeclarative expression, QDeclarative script string. The only reason you will ever need to use them is when you are doing some sort of UI automation and testing. Otherwise, just don't touch these classes. A nice advantage of this approach is also that you can actually write UIs which are not QML based. You can actually do a HTML UI. In fact, we are thinking of having a HTML based front end to Qt Media Hub. All the media services and the backend stuff is in the C++. We are going to inject all these C++ things into the web page, and the web page can access all these to create a UI. So there are two fundamental ways by which you can extend QML through C++. The first way is by registering a type. You can take a C++ type and you can expose it to QML. This is the syntax. The code is really not important. What I want you to see here is the concept or the idea. You have a myButton class in C++. You expose this to QML using QML register type. And then you have the QML code itself, which can create new myButton objects. Fairly straightforward. The second way is that instead of exposing a type, you actually expose a C++ instance, right? The way to do this is using this snippet of code. What you do is you set a context property. Here, person is actually a C++ instance, and we expose it as a context property. And then in the QML, you can just access this as person.name. I'm going through these things very fast because this is fairly basic, but I just want to get the flow. So my suggestion here is that you should never really use context properties. You should always register QML, you should always register C++ types, and you should expose them to QML. And a strong reason for this is that now QML has complete control over the lifetime of the object. So take, for example, in Qt Media Hub again, right? We have the picture model. The picture model consists of all the pictures. So it might have like 10,000 to 20,000 items. The QML is the only thing that knows whether any picture-related stuff is being shown on the screen. The C++ has no idea, right? We decided it upfront. C++ has no idea of the UI. So now the skin knows whether pictures are being shown or not. So it can create and destroy a picture model object anytime it wants. Had you chosen the latter approach, which is basically to register a context property, the lifetime of a context property is pretty much in the C++ side, right? The only use case I know of to use context property is when you have C++ singletons. And in general, singleton is a bad pattern anyway. So yeah, there's very little use of using context properties. Okay, so far? Does anybody have any questions? Yeah?
Please wait.
I have an application that communicates with database, and I create context properties, but the classes are non-creatable by QML.
Yeah.
How would I fix this approach, and what's wrong with this approach?
So what's wrong with this approach is that on startup you create this database class, right?
Yes.
So it's going to load things up in memory.
Yes.
But the UI may not even be showing this stuff.
Yes.
So what's the point of loading these things in memory, right? So in Qt Media Hub, it's pretty much the same thing. The whole thing is actually stored in a SQLite database. All your media information is in a SQLite database. But the models are actually creatable on the fly. And depending on what you see on the screen, the QML creates these items and destroys them.
Okay,
yeah.
Thank you.
Yeah. Okay. So to expose a C++ type to QML, it's fairly straightforward. You just make it a Q object. You just use the stuff even which were available even before the QML world. You expose properties as Q_property. You have signals and slots which can be exported to QML. There is also a macro Q invocable, which we can use to export functions. The main difference between a slot and a Q invocable is that a slot is something which the API says it is something which you want to connect to. A Q invocable is something, it's a method which returns a value. An example of a slot is something like refresh. You might want to connect a timer event to refresh. So refresh is a nice slot. But let's say you have a function called media count. Media count actually returns a value. It doesn't make sense to make it a slot. It makes sense to make it a Q invocable. But in reality, slots and Q invocables, the implementation is the same. Yeah?
In the case that you just described, the media account, why not make that a property?
I would make it a property too, yes.
So are there any uses for Q invocable beyond properties and slots?
Yes, sometimes you have functions which take parameters. So you might want to want to have a function media count of a particular artist, for example. So that would be a Q invocable as opposed to a property. Yeah. So my general suggestion is, like I just mentioned some time back, make things as properties as much as possible. Properties make it binding friendly in QML. The way QML finds out if a property has changed is using the notify signal. So if you see below Q property, Q string, blah, 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 notify text change. So every time the text change signal is actually emitted, QML figures that this property has changed. One interesting fact is that I'm sure all of you who have coded in QML have hit this binding loop thingy. QML determines binding loops at runtime. It is not determined at compile time. I mean, if it was compiled, if it determined at compile time, it could have already told you, right, when you were writing the code. It is actually detected at runtime. And what it does is that when it makes a property assignment, it keeps track of all the signals which have been fired, right? And when it sees that the same signal has been fired twice, it says that there is a binding loop. What this means is that if you want to, let's say you have a two-way binding, like a property A depends on property B, and a property B depends on property A. This is actually sometimes needed. You are going to hit this binding loop issue unless you take some precaution. And the precaution is essentially that in all your property setters, when the new value comes in, make sure that you emit a signal only in the value has actually changed. So you would say if old property value is equal to the new property value, just return. Don't do anything. Otherwise, set the property, do whatever you want, and emit the signal. Right? There's also this infamous error which says, there are also cases where you sometimes want constant properties. So here I have something called text. Let's assume that this is just initialized on startup. It never changes. And then you say, why do I need this notify thing anyway? Because it never changes. And you remove the notify. And then QML complains saying that you are trying to bind to a non-notifiable property, right? The way to avoid that is to actually use the constant attribute. If you mention constant, QML will assume that this property never changes. There is also the final attribute. Sometimes it makes sense to make sure that the QML does not shadow properties from C++. An example is x, y, width, height, all these properties of items. It is very unlikely that you want to create your own properties named x, y, width, height on the QML side. So what you can do is you can mark properties as final in the C++, and the QML will actually later tell you, it will give you a warning if you try to create new properties as the same ones as the C++ ones. So if you say property int x, on any item in QML, it's going to give you a warning because x is marked as final in C++. If you look into how QML works, so QML is essentially like a tree, right? I mean, you specify like a document, you have children nodes in the top level item. If you think about how it actually works, everything is really a property assignment. So if you have an item, inside the item you have a rectangle. The rectangle is actually a property assignment. What happens in the background is that QML tries to figure out what is so-called default property, and it will assign all these child elements to the default property. So rectangle is assigned to the default property of item, and it so happens that item's default property is actually children. That's not entirely true, but yeah, that's the way it works. So all the children, all the child items inside the main QML get automatically assigned to the children property of the parent item. If you want to have the same behavior, you want to change the default property. Let's say you have a fancy item, but you don't want these to be like children. You want these to be assigned to some other property. You can use q+info to mark a different default property. You can also use qenums to register enumerations from C++. There is also a facility by which you can just export enumerations, but you can also mark the type as non-instantiable. I think the function is QML register uncreatable type. It's just so you know. You can look it up in the documentation. So when designing your C++ class, you should try to group all related properties into a separate Q object. So let's assume you have a class called button, and it has a lot of style attributes. What you can do is have a separate object called style, and inside style you can have separate properties like color, frame width, and shadow. What this provides you is a nice little syntax which is specified here. If you didn't actually create the style class, you will have to mention something like style color :red, style frame width :3. It's just cumbersome to type, and this is just nicer and cleaner to read. If you think about the syntax of anchors, where you say anchors.top, anchors.bottom, it's basically a group property. One limitation you need to know is that if you have multiple signals in your C++, which have the same name, but different parameters, QML can connect only to the last one. This is just a limitation, so just go ahead and rename your signal to be something else. You should also try to avoid Q-variant property types. Be as specific as possible. If you know that some property is a color, use QColor. If you know something is a rectangle, use QRect. The basic problem when trying to use a Q-variant property is that QML tries to do all sorts of magic to convert strings into a Q-variant type. And that code path is really slow. I'm not sure, have some of you seen random errors, like it would say unknown color with, stuff like this, unknown color, like random stuff. And you are like, I never assigned a color called this thing ever. Why am I getting this error? You get this error primarily because of this. QML tries to do some magic to convert a string into a specific type. It tries to convert a string at some point to a color, and QColor's code essentially emits that warning, saying that I don't know this color. So in QML, you can actually expose a QString list or a QList of objects. You can use them as the model for the views in QML. This actually works very well, and it's convenient. But you need to understand what are the implications of this approach. QString list is actually not a Q object, right? It is just a normal type, which essentially means that QML cannot possibly know what has changed inside a string list. So if you started out with a string list which had 3 items, later you insert an item at position 2, QML has no way to know that you have actually insert a new item in position 2. What this means is that all the views which had all these animations, list view on add, list view on remove, all the fancy animations, they are not going to work because it's going to behave as if it's like a reset, right? There was a QString list before, and there's a new QString list now. The way to work around this is to actually use QDeclarative list property. QDeclarative list property is sort of like a wrapper on top of a QList. It provides a mechanism by which QML can be notified what exactly is happening inside the list. When you design your C++ class, you have lots of properties being set. So let's assume that you have, in the QML, you set 10 properties. What you would do usually in your C++ is, after each property changed, you would do something, which essentially means that if 10 properties are set, your C++ is probably going to do the same thing 10 times, right? And this is very inefficient. So what you can do is derive from this interface called QDeclarative parser status. It has a virtual method called component complete. And that method is called once all the property assignment in QML has been completed. One of my favorite classes is QDeclarative property map. QDeclarative property map provides a mechanism by which you can collate QObject instances and you can expose it to QML. So as an example, if you have two QObject instances, let's say A and B, if you just put them in set context property A, set context property B, B, in the QML you would actually access these as A.property, B.property, right? I really don't like that approach because it is not clear where this A came from. A is this magic context property that got set in QML. What would be nice is if there's an explicit mechanism to mention this is actually coming from the C++. You can do that using QDeclarative property map. You take a QDeclarative property map. You take your objects A and B and insert them into this property map. You call your property map as runtime and register this runtime object into the context. What this means for the QML is that you would now access things as a runtime.a.property, a runtime.b.property. So every time you see runtime, you know that this is something to do with C++ stuff. No, at least not noticeably. I'm sure it's slower than the other approach, but yeah. So that covers the C++ bits. Let's move to the next layer, which is the QML layer. Of course, this goes without saying. You need to start thinking declaratively, and the only way you can do this is by writing a lot of QML code. Use states and transitions as much as possible. Initially, it's a bit hard to get into this mindset, but yeah, at some point you will get there. One of the things which I've seen in QML is that QML makes it so simple to write badly written UIs that people have this humongous C++, humongous QML file which does a whole range of stuff. It is important that we don't forget our C++ lessons of data hiding and encapsulation. For example, let's take the screen here, right? The screen has a list view on the left. It's a bit hard to see, but there's a list of items on the left. There's the weather and the date and time stuff on the top right. And there is a button control list on the bottom left. How you should approach this is thinking in terms of components. You should say the thing on the left is a list view. It's the root. So I'm going to put all this code into root menu.qml. You take the top thing, the top header as another component. You put all that code in header.qml. The button group below, you call it control list.qml. And then you create main screen.qml. Main screen.qml composes all these three components and positions them appropriately. Don't try to put all the code in a single place. So all the lessons we learned from C++ still apply pretty much. Another thing is that you should use signals and slots for interaction between the components. Let's assume that the movies item is actually clicked. It shouldn't be the responsibility of root menu or the list.qml to actually show the new video window. Instead, what should happen is root menu.qml should just emit a signal. And in the main screen.qml, you attach to the signal and actually show the window. So it's pretty much what we would do in the C++ world. We just need to make sure that we follow it. So I stole this slide from the documentation. It provides the coding structure for QML, and I think this is kind of nice to follow. First, you have the IDE. Then you list the property and signal declarations. Then you have your JavaScript functions. Then you list the object properties. Object properties are basically the ones which you assign to from your parent item. Then you have your child objects, states, and transitions. What's nice about this is that you list your public API first, right? All your properties, signals are part of the public API. So if you open a QML file, the public API is right there in the front. Rest of it, like child objects, states, transitions, all these are just implementation details. Dynamic scoping is a complex topic, so I'm going to try my best to explain this. Each component in QML has something called the component scope. So you can has something called the component scope. The component scope determines how the lookup of variables is done. The component scope is actually the union of the IDs and the properties in the QML. When a component creates another component, they form what is called the scope chain. And the lookup goes hierarchically. So if a component creates a component, each lookup is like first it will look into its own scope. If it's not there, it's going to go and look up in the parent scope. If it's not there, it will go to the parent scope. So this feature of QML is called dynamic scoping. I would really like to have a way of disabling it actually, but it's there. And I've seen many people abuse it, and an example is here. If you see parent.qml, it has a property called duration with a value 10. It has a child element called child. And in child.qml, notice how you can actually access p.duration. this whole access mechanism works simply because of this whole dynamic scoping, right? Two QML files should not be so tightly integrated to start with. The only reason you have such kind of code is when these two QMLs are split up into separate files only because the file has become too large. So an example of this would be parent.qml is really listview.qml, child.qml is like listviewdelegate.qml. I mean, the list view and its delegate go alongside each other. They are really one thing. So it's okay to have all this kind of code between tightly bound components. But in general, it's a bad idea to do this. How I would do it instead is the child element should expose a property called interval. And then in parent.qml, I would set child's interval property. Right? So now the child can change independently of the parent. So there are a lot of complications with the whole dynamic scoping. If you want to have some fun after this, I have a lot of examples. It's like a quiz to figure out what actually happens. So in general, always access things, always prefix access of properties with an ID. The only obvious case to me is when you access a property within the same element. That's okay. But as soon as you access parent properties in a child element, always prefix it with an ID. You should also be careful of the modules which you import in QML. The way it is in QML right now is that if you import a module, but let's say you don't use it, it's going to load that module anyway. So if you import Qt WebKit and you just don't use WebKit throughout your QML, it doesn't matter. QML is going to go and load the QML WebKit plugin. Yeah, so you should be very careful about that. Yes?
You've mentioned this problem with scoping.
Yeah.
With slots in QML and with accessing modal data, you don't actually have the parameter names explicitly. You have to look in your C++ code and read them from there. Are there like design patterns around here, like using a prefix or something like that could help so that there's no, I mean, technically, it will look in the closest context, but from a readability point of view, it's not really obvious what's happening. Where did that variable come from in this delegate or things like that?
Yeah, I completely agree, actually. So I think what he's saying is that if you have signals with parameters in your C++, in QML you would, so let's say you have a signal called foo, and on the QML side you would say on foo changed, and the arguments are just magic, right? The argument names come directly from C++. To be honest, I don't know. I think there's actually a deficiency of the language. This actually needs to be fixed. Yeah. Okay, where was I now? Yeah, so one thing you should keep in mind when you connect in QML, when you connect and create slots like on property changed, QML actually suppresses signals during the component initialization. So your on property change will actually not be called on startup. Unfortunately, there are a few cases where these things will fire. So you might be mistakenly led to believe that this actually works. And you put some of your initialization code in there. So remember that on property change is actually not guaranteed to fire during the initialization phase. If you want to have some code during startup, during initialization, the right place to put it is in component.onCompleted attach property. So this is the C++ equivalent of QDeclarative parser status. Yeah, QML makes it all too simple to copy paste code everywhere. So I've seen the same element being repeated like many times. If you see that happening, that's about the right time to make a component. My advice in general is to keep components as simple as possible. To give an example of what happened in Qt Media Hub, we ended up with this button which can display text, which can display images, which can be checkable. It can be a radio button. and it was this big unholy mess. It was just a bad idea. What would I do today? I would just make separate components. I would make checkbox.qml. I would say image button.qml, text button.qml. If there is no real reason for these features to exist in the same file, they shouldn't. Just create separate components. Just keep things simple, right? Remember that at some point, a designer will hopefully come in and beautify your code. So it's nice to keep it simple. When you design components, you can hide the internal implementation of the components using the depointer approach. This is basically the pimple approach in C++. What you can do is you can create a Qt object. A Qt object is essentially a Q object to which you can add properties in QML. So here, click, cost, focus is an internal property of the line edit. There is no way that users of line edit can actually use click, cost, focus, thanks to QML scoping rules. One suggestion I have seen is to call all your internal variables to prefix all your internal variables using underscore. So you would say property bool underscore click, cost, focus. That works too, whichever you prefer. The only difference is underscore properties are still accessible from the users of your component. If you use the depointer approach to hide all your private variables one level deep, they are not accessible. This advice is again specific to components. When you design components, so let's say you're designing your own button, right? Button.qml, it has a specific set of states and transitions. But this is supposed to be a component. And imagine the user of this button. He wants his own states and transitions, right? As soon as he goes and sets the states and transitions property in button, all the underlying implementation state and transitions of the underlying button is going to get overridden, right? And you don't want this to happen. So when you do components, you should stick in all your states and transitions into a separate state object, and this state object in QML is called state group. Really, I just pasted some code in there, but you just need to know that there is something called a state group. Go to the documentation. It's fairly easy to use it. So for components, don't use the states and transitions variable. Leave it to the user of your component to use it. I have some other tips. In Qt 1.0, the width and height property have dual meanings. It is the width and intrinsic width and height of the item. So if you have some text, you can query the width and height of the text item, and it will be the same as the width of the text. But you also use the same width and height property to actually set width and height of the item in your scene. The problem with this approach is once you set a width and height, there is no way to access the intrinsic width and height of the text item. In Qt 1.1, we have separate properties called implicit width and implicit height, which always refer to the intrinsic width and height of the item. And these are very useful to have when you design your own components. There is also a property called childrenRect inside item. ChildrenRect is useful to provide a size hint for your composite components. If your component has multiple child items and you want to know what is the size of all these items put together, there is a property called childrenRect. ChildrenRect is the bounding rect of all your child elements. Just like in C++, you could do QClassInfo to specify a default property. There is actually a default keyword which you can attach in all your property declarations in QML. Again, this is useful only when you create components. I stole a lot of ideas actually from the Qt components project. So if you want to see more ideas, yeah, just go look into the code. So we have covered the C++ side and the QML side. Let's see what we have on the JavaScript side. In QML, if two different QML files import the same JavaScript file, the JavaScript file will actually be loaded twice. So if you have a foo.qml which loads a JavaScript file and a bar.qml which loads the same JavaScript file, each QML file gets its own private copy of the JavaScript code, right? But if you know in advance that the JavaScript is actually stateless, so let's say it's some math library or something, what you can do is you can stick in this line .pragma library at the beginning of the JavaScript file, and then QML will have just one instance of the JavaScript, which will be shared between multiple components. You need to know what are the side effects of this. The side effects are essentially when you have a .pragma library, you cannot access your QML stuff anymore. So that's a pretty big limitation. The second limitation is that you cannot use the JavaScript as a way to share variables across QML. So these are the downsides of this approach. There is also this cool thing called Qt.include, which you can use to import external JavaScript files into an existing JavaScript file. We should also remember that when you have code like this in the global scope in JavaScript, this won't work because one of the first lines in your QML is import foo.js, right? And foo.js is actually loaded at that point in time. It's actually executed. The component is not created yet. The items are not ready yet. So none of the QML is actually accessible in the global scope in JavaScript. The way to fix this is in the QML component.onCompleted, you call a function to initialize the JavaScript stuff. In Qt Media Hub, what we have is this. We have these different skins, right? And each skin wants to represent media in a different way. So if you take the music window, for example, the Delphine skin wants to show like a flat list of all the media items. The Confluence skin wants to show something more hierarchical. It wants to show the list of all the artists. You step inside the artist, you see all the albums. You go inside the album and you see all the songs. How do we make something like this happen? Because on the C++ side, all models are Q abstract item models, right? And usually when you write a Q abstract item model, you have to decide upfront, is this going to be a list? Is it going to be a table? Or is this going to be a tree? The way we did it in Qt Media Hub is to actually create an abstract item model whose structure can actually be configured. So here we have the media model, instantiable from QML. It says that I am interested in audio items. And the QML actually sets the structure. The QML decides the layout of the model itself. The string here essentially means that first show the artist, in the next level show the albums which are related to the artist, and the third level should be the songs in that album and that artist. In general, this is a common problem, so which is why I have this here. Is this clear? Do you have any questions on this? This is essentially the way by which your QML can decide on the layout of your model. I put in this trick because it's one of the most frequently asked questions on IRC. And the question basically goes like, how exactly do I access the model data associated with a delegate? And the answer is basically that the delegate is, each delegate is a component. The component has a component scope. To each component scope, QML attaches a property called, it's not an attachment, it's a context property called model. So you can say model.foo inside your delegate, and it will actually fetch the data role associated with foo, model.bar, it will fetch the data role associated with bar. What you can do in your delegate is that you can expose this model context property as, let's say, model data. So my delegate exposes the model as model data. And then in your list view, which uses my delegate as its delegate, you can access the current item model data name. So this is the name role associated with the model data for that delegate. It's a cool trick to know, very useful. So I'm going to just pass over graphics performance and stuff because there are already talks which cover these in depth. The main thing to remember is that QDeclarative view at the end of the day is just a QGraphics view. QGraphics view at the end of the day is a scroll area. Scroll area is just a viewport, has a viewport, and it's a QWidget. So all the performance stuff which you know about QAbstract scroll area and QGraphics view still apply to QDeclarative view. If you want to set up a GL viewport, you can just use set viewport, new QGL widget. You can also use all the WA underscore obscure flags to achieve transparency and stuff. To be honest, I think all these flags are very tricky to use. They are also very platform specific. They are also depending on the fact whether you use an OpenGL viewport or not. You can find sample code for this in Qt Media Hub, but it is possible for you to actually overlay QML on top of video, and you can see it in the demo booth again. You will see the video shine through the QML, and the QML is rendered in a separate layer. The QML is the video is in a separate layer, and the QML is in a separate layer. So this is entirely possible. It's just a matter of putting in a lot of time. One of the things which we learned when running Qt Media Hub and lots in all the embedded devices is images work best everywhere. So you should make your QML as image friendly as possible. If it's possible to collapse multiple items into an image element, you should. If you have like a rectangle which has some sort of a drop shadow effect, you can do this by creating a rectangle, and then you have an image element which draws the shadow. Instead, think of a way by which you can have the rectangle and the shadow as a single pixmap to start with, and then you can use the border image or something to actually draw the rectangle with shadow. So use images everywhere. One nice property to know is the image elements source size property. So by default, QML will just load images from the disk, and if it's huge, it's going to occupy all the size in memory. If you set the source size, it will scale down the element to this particular size and keep only that for manipulation. One unfortunate thing is that QML has its own image cache. It has its own QPixMap cache, but it's not the same as QPixMap cache. So QPixMap cache can actually be configured by setting the cache size and the cache limit, but QML has no such thing. If you feel about this, you should go and vote for that bug. Yep, there's a lot of QML stuff which I wanted to cover, but it's kind of hard. So I'm just going to run over these items quickly, just to know what's happening in the QML world. One thing which we wanted is downloadable skins. We wanted to be able to download entire QML files as a single package and run it for Qt Media Hub. One approach for this is to actually use this QAR file handler. You can go, it's part of QML Arsenal. What it does is essentially provide a QAbstract file engine handler. One of the downsides of QAbstract file engine handlers is that it actually pollutes the global namespace of Qt. So if you go into your file dialogs, for example, QAR files, even though it is a file, it will start acting strangely because you injected this new special file engine handler. So currently in Qt Media Hub, we actually implemented using the QAR approach, but we are moving to a QNAM-based approach. QNAM is Qt Network Access Manager. What we do is that we register a custom network access manager with the engine. All skins have a special scheme associated with them, which is the QAR scheme. So when QNAM sees that there is a request for a file with a special scheme, with this QAR scheme, it would create a custom Qt network reply object and provide it. Yeah. So that's the approach we are taking to handling packaging of QML. Ideally, I'm hoping someday that this will actually be a part of QML itself. We also have an app store inside Qt Media Hub where you can download arbitrary content, arbitrary QML stuff from the web and run it inside your media box. As we saw in the dynamic scoping section, what this means is that apps can actually access parent context, right? So random QML stuff which you downloaded from the web can now go and change your parent states and transitions and whatnot. So this in general is a bad thing. So it would be nice if QML provided some sort of sandboxing to allow QML applications. Just 3-4 days back, there was a mail about a sandbox loader. Again, it's part of the QML arsenal. What it does is essentially create a new Q declarative engine for elements that need to be sandboxed, but it has a lot of limitations. But currently, there is no easy way of doing this in case you are looking into this. Qt Media Hub also runs in various targets where mobility is not present. We want to display video, right? And we want to use the video item of mobility. But in lots of targets, we have special APIs, special C, C++ APIs. Some of them have a dbus API. How do the skins use a video element that can be used agnostic of what platform they are running on? So what we have is a technique called dynamic module switching, where the implementation of video gets switched at runtime. Again, the trickery can be seen in the code. Qt Media Hub also runs in various targets of different resolutions. To be honest, we haven't actually found a good approach by which we can use the same QML with multiple resolutions. The closest we have is something like show the top level element full screen, and all the child elements are essentially relative to this top level element. So for example, if you remember the Confluence screen, the list view would say I am 30% the width of the main screen. And that's pretty much all I have on resolution independent stuff. But I think Donald has a talk on resolution independent UIs where he will cover more. Keyboard focus. I actually had a slide on keyboard focus, and I tried to explaining to people how it works. It turns out it's an extremely complex topic, and I completely failed in explaining how this whole thing works. If you're interested, I can show you how it actually works, and I need a pen and paper to actually explain it. It's impossible to explain that stuff on the stage. So yeah, we spend, I think, there's so much code in Confluence, our skin, which is related to focus handling, which is basically wrong. But unfortunately, we don't even know how to do it right. Because focus scope is fundamentally complex and hard to understand. So if it makes you all feel any better. So that's it. Thank you. So if you have any questions, to take them up.